Hello again, YouTube. Sorry about a long delay. Combination of being busy and a few technical problems, but hopefully they're behind us and I can crack on with this. I last left it and we looked at RS-232, a protocol from the 1960s, which basically turn a line high and low, or switch a line high and low to create a pulse, which is ASCII code. And then that was 2 videos ago. Last video I just looked at setting up a hierarchy of Git projects or repositories so that we could have lib soup in our projects, and I added it into this CB getting started project. So now, why would you use a 1960s protocol RS-232? We did look previously at the MPPT solar charge controller, which had a serial interface on it, and it actually had converted that serial interface to a Bluetooth with an additional piece of kit. If I just move these aside, this little dongle basically converts the RS-232 on this little connector coming from the solar charge controller into Bluetooth, so you can just look at what the solar charge controller is doing on your phone or your tablet. So why would you have just gone with serial and not just gone straight to Bluetooth? Partly it's simplicity. Serial interface is just so easy and cheap in terms of both financially, because ultimately all you're doing is switching a GPIO pin on and off. So cheap in that regard, and cheap in terms of like the actual silicon resources, the microcontroller power that's needed to do that is trivial. So it's very easy to put onto a product. Now that doesn't mean that like lots of products will have Bluetooth and USB built in, but for myself and the cinnamonBun in this example, I have a 3-pin header which I never discussed, and it's not really a GPIO, and it's situated there on the USB based version, and I moved it over to there on the non-USB version, but both are the same. It's just you've got a ground connection, which is that pin is actually just connected directly to the ground plane of the board, and then you've got the 2 other GPIO pins. Now, because of microchips peripheral programming, you can set that to be a receive and that to be a transmit, or the other way around. The same is true of this board. Ground is on the left as you're looking at it here, and then the other 2 can be receive and transmit, or transmit and receive, depending on what kind of a connector you're using. I generally use the FTDI Raspberry Pi. Well, they sell it as a Raspberry Pi based serial connector. So all I have is the 3 pins. The black in this case is the ground connection, and yellow is receive, orange is transmit. Now when you connect these things up, it will be connected. Connect the receive side of one device to the transmit side of the other, and vice versa. So receive to transmit and transmit to receive. So, and that is like I suppose the hello world of embedded system, a small embedded device, is a LED, and we looked at that. We've looked at LEDs and switches, but that hello world is it shows that things are up and running. But then when you go to do something more difficult or more complex, then having a serial interface is a godsend. And if you look at the reason I have it on these boards, and the reason most devices would have it, it's kind of a bit shiny there, but that is labeled as the debug port, and that's basically all I have it for at the minute. Now the way I program, I throw printfs all over my code when I'm developing, check that everything comes out the way I'd expect it, and then remove them when a project is like in production, it's been tested and you know it's working. You can strip down all those debug messages, so all the logging comes out of the code. So I'm going to add, we're playing with this getting started project, and I'm going to add serial logging to that project. Now it's been a while, so this IDE is going to take me a moment to get the hang of. Actually, I should check that this actually builds before I start. I haven't done anything, so it should build, but the IDE is sometimes a bit right. So the last videos we looked at, that we went through the config file and added serial logging. Not serial logging, sorry. We added serial communications with UART. So we had to define sysUART to include that section of code. And along with that, you have to define the size of the transmit buffer. Now I'm not entirely happy with my implementation. I'm probably going to refactor that, because at the minute, if I'm running 10 UARTs, communications, serial communication channels, they're all using exactly the same size of a transmit buffer, and that is a bit yeah, I don't think that's efficient. I think it's probably better to have that as a configurable item in the configuration that you're sending down to the serial port API, and say that, like, I want a serial port and I want this size of a buffer. So in future I'm probably going to be, one of the problems with that is that it's dynamic, and then you're taking memory out of a heap, whereas if you've hard coded it before in this mechanism, the buffer size is defined at compile time, so there's nothing coming off a heap. But yeah, I'll figure it out, and I may refactor it. Having included serial, then we have to add serial logging. And I said that the 3-pin connector was because of the microchip peripheral programming of the pins, the I/O pins. That debug logging port can be in 2 configurations, so we have to specify. I'm going to go with ground RxTX. So the alternative obviously is ground TXRX. So that's my pin configuration, and I have to connect up my USB cable. So log level, I have got 4 levels. Lots of code has a different. I've got log, information messages, warning messages, and error messages, and I think that's sufficient. If I suppose it could change in the fullness of time, but at the minute, debug, info, warning, and error it seemed enough. Debug is the most verbose, and so when you set this syslog level, when you define this, you're setting how much of the printf, how much of the logging information is actually output to a serial connection at runtime. So obviously then we need a baud rate. I've kind of been going 19K2, so 19,200. So I'll stick with that for the minute, but you can go higher, and that's it. So if I build that, I'll do a clean build of it. That we've added in, by adding those into our configuration file, we've added that functionality into the build. Now at the minute our main.c isn't actually using it. We were actually using just timers up to this point. So there's a few tricks to this. And so we need serial log.h. Now that file defines usually with C code you would use printf when you're adding if you're outputting something on a serial interface, it's printf. It's an old function going back forever to the earliest days of C and the first Kernighan and Ritchie Hello World example. So that function, I've not implemented that function, or Microchip have actually implemented that function. So the libraries you get with the DSPIC33 include a printf. Now that printf assumes that you're outputting on the first serial port. So and that printf is quite complicated and prints out a lot of different types of information. So it'll print out floating points and doubles, and my code at the minute doesn't use floats and doubles. So I've implemented my own and called it that serial printf. So instead of using the standard printf, I've actually added a serial printf. And I've also added a serial log. But in order to make things easy in terms of adding and subtracting debug information, these macros, log D, log I, log W, and log E, will output a logging message, but it's also surrounded in defines, so that depending on the log level that is set in our configuration file, these may or may not be output at runtime. So even though they're in code, they may or may not be compiled in. That depends at compile time what this configuration file. And there's also another switch, a debug file. If that is defined, or if that is not defined, then it just removes all the debug info and warning messages. So when I include this header file, serial log.h, I have to define debug the file. If I commented that out, then any log messages I would have there. So I can simply add, instead of doing a printf, a convenience function is just log d. That's a log debug message. And so it's a stupid piece of information is entering main loop. And the one thing that we haven't done is that that variable takes a tag, or that macro takes a tag, or a variable name tag, which is the source of this logging information. So if we want to see where exactly this logging information came from, we have to add a variable called tag, and in this case I'll just call it main. So when this when a logging message comes out of this, we'll say it's the main, it's coming from the main file. So all of the subsections of code would have a different tag to describe where they're coming from. It's very much like Android logging information in an Android app, if you've ever written an Android app in Java. So we can do log D, we can do log I, log W, and last but not least log error, and loads of exclamation marks to prove the point. And that's it. So like I say, if you look at the serial login function, you can use serial printf, my implementation of serial, of the printf function. Or you can actually call directly serial log, which will log a message as well. And in that case, you pass it a level of logging, which is this. In the case this case, it's hard coded into the log function of that macro log d as log debug. So if I did that, in that code, it would just be, I'll ignore the result coming from it and just say serial log. We want a debug message. Our source of the tag is a tag, and then our message is hello world. The disadvantage of that is that I can't switch it on and off. Using switches, as I can with these macros, because these macros are surrounded by various if-defs. But I will check that it builds, and we'll try and like I say, it's very much dependent on how somebody codes. And a lot of people, when they're developing code, they will just go straight to JTAG, Debugging Interface, and I tend to use that in as a last resort. Yeah, one of the things that PicKit is doing now is, or MPLab X IDE, is it won't recognize a hot plugged PicKit 3. It used to, but for some reason, because I've just plugged in a PicKit 3, I have to restart MPLab X and try again. There's lots of things about this IDE that I'm not a huge fan of. So if I try and program it now, right. So my serial connection I'll have to get rid of this PicKit 3 for the moment, and my serial connection is, I've said ground or XTX, so I need this cable in a certain configuration and plug it into my USB. So now if I do, I'll just use Kermit. I kind of bounce between Kermit and Minicom for my serial, and Kermit is considering it. Am I not in the group? Yeah, I mustn't be added to the dial out group. I've reinstalled operating systems a few times. So I'm going to set the speed. I set for 19K2, and carrier watch off is one of those things I have to do in Minicom and connect. And now if I turn on, I think there's a pause at the start of that. So now we've got two debug messages and an information, an error, and a warning and an error, and that's the first letter of each line. And the source of all these messages is coming from my main. Now if I go into, if I change the configuration, actually I better plug in my PicKit3 again. If I change my configuration, this is the advantage of logging, is that I can now say, well, I don't want debugging and information messages, I just want log warning and above. If I could spell. And if I program that into the device, now there's a pause, this should be running. That's been held to reset by PicKit. We'll try and cycle the power. There we go. Yeah. So we've removed the debug messages that were like the log D and the log I. The other message, which was just calling the serial log function directly, hasn't been removed because that isn't surrounded by the if defs, and so it's, that's one of the advantages of using just those little macros, log D, log I, WNE, is that you can just remove code. And if I get rid of the debug file and program that up, I'm having to connect and reconnect my PicKit3. It's holding it in reset for some reason. So if I remove the definition of debug file, then I'm only going to get error messages. And again, the hello world was a direct call, not through switches. So my last, just as a last example, if I go to my configuration and remove that serial login define and download that, oops. Another one of the advantages of using log D and log I is that this isn't going to be defined. So if I compile, edit that out, so now this is a poor example because now when I turn on, there's not going to be any output at all because we've just defined out system logging, and those logging messages can still be in the code. There's no problem with them being there, but they're not compiled in at compile time because of the switches that are surrounding them. And that's it. That's serial logging. And as I say, like C++ programmers don't like printf and probably debugging in using different mechanisms because they just connect a debugger. But in my case, in little embedded systems like this, just serial port and connect up and see what's happening inside. until you get a serious problem. Now there are drawbacks. If there's a timing issue, then like adding a printf is going to change the timing. So if you're debugging a race condition, the printf is going to make things even worse because you've changed the timings, so you've no longer got the race condition that you would have had. So that is one of the drawbacks. But for the most part, printf is a very easy go-to in terms of debugging a piece of code. I'll leave it there. Hopefully it won't be as long the next time. Thanks a million for watching, and talk to you soon.